In this video, we're going to tackle task 7C for the digital electronics notes. Once again, we are required to take a truth table and turn it into the diagram for a logic circuit. As before, we're going to identify the rows in the table which have Z as a 1 in the table. And for each of these rows, we're going to write an expression for Z in terms of A and B with the letter with a bar if it's a 0 in the A or B column, and the letter without a bar if it's a 1. So our first row that has a Z is a 1. Second row of the table, we have A0, so we'll have A bar here, and we've got B as a 1 in this row, so we'll have dot B. In the third row of the table, the row below, we have A as a 1, so we'll have A, and we have B as a 0, so we'll have B bar here. We have two expressions for Z, so that means for the whole circuit, our overall expression will be these two added together, telling us that either A dot B with A as a bar, so not A and B, or A and not B are the combinations that will give us a positive value for Z in the output. So we want to draw this diagram now. So Z is equal to not A dot B or A dot not B. As we've seen previously, because we have that plus sign, we have an or. Either this expression or this expression will give us a 1. So these two expressions will be the inputs to an OR gate, which appears just before we get to the end of our circuit. So we have an OR gate here with two possible inputs to that. And these inputs come from either side of our plus sign, A bar dot B and A dot B bar. Now we can see these have a dot between them. These are both AND expressions. And as we're working from right to left, we want to have individual letters, because over here, we're going to have A and B as the possible things we can connect to. So both of these will have an AND gate in front of them to separate these on either side of the dot sign. So in this gate, we're going to have our inputs A bar and B. In this gate here, we're going to have the inputs A and B bar. So we now can connect some of these inputs directly to what we've got on the left-hand side, and some of them need to pass through a NOT gate first before we do so. And one of those is the first input to the top AND gate. We have A bar, our input is A, so we need to put a NOT gate in here. So our A signal can pass through this NOT gate, and we can connect it up to the input to the AND gate. A passing through this NOT gate gives us A bar, which is what we require for the first NOT gate. We also need an A going into the bottom AND gate, and this time it's A without the bar. So we can take a connection from before where the NOT gate is and join this up to the second AND gate. B is required for the top AND gate, so we can draw a line here, joining it up to the top AND gate. And B bar is required for the bottom AND gate. So between here and here, we have to insert a NOT gate so that we get B bar as our input. And we install a NOT gate like this. It's always important we track across our circuit to check what's happening. So we want to see this as B here. We can follow the line back and see, yes, this is B. But if we wanted to check this as B bar, we're coming back and good. It's a NOT gate. So that means the B coming out of here becomes not B before it gets to this AND gate here. And this concludes task 7C.